All right, everyone. Hopefully the live stream is working. It looks like it is from my end, so here's hoping it is. We're going to be going through the bonus review that I put up on Google Classroom. So if you did it, that'd be awesome. If you didn't do it, that's okay. You can still follow along anyway. There's an answer key up on Google Classroom too, in case you need that. If you do have any questions, feel free to type those into the chat window. I'll be checking that periodically throughout, and I can answer any questions that you have. But for right now, we're going to start with going over absolute value. So the first one's a basic absolute value problem. And the whole idea with absolute value problems is that you can't add or subtract or multiply or divide anything while it's inside the absolute value. So what you do is you basically take what's inside and you set it equal to the two possible answers that would make the absolute value true. So in this case, 3 and -3. And then you're just going to solve those both for your two solutions separately. This is one of our big things on this test is you want to make sure that you have two solutions. Okay. So I'm just individually solving both of these by getting the, I don't know why I changed that to a y. That was pretty weird. Let's try that again. So I got -2r equals -4. I'm dividing by -2. And I get r equals 2. I do the exact same thing on the other one. I subtract 7. I get -2r equals -10. And I divide by -2. There are my two answers. And if you check both those out, if you plugged them back in for r into the original equation, they would make the equation true. Now, the big difference with problem number 2 is that we have something, in this case a -7, outside the absolute value. So I can't write my two equations right away. Okay, I don't want to make equations with the -3 on the other side. What I want to do is I want to isolate the absolute value first. So I'm going to do that by adding 7 to both sides. Okay, to basically get rid of that -7. Now I've got -5 plus a equals 4. At this point, this is the point where I want to write my two equations. I want to say I've got -5 plus a equals 4 and -5 minus a equals 4. I'm going to add 5 to both sides. I get a equals 9. I'm going to add, oops, forgot to finish my plus sign over there. I'm going to add 5 to both sides. And I get a equals 1. Okay, so again, you're isolating the absolute value. You're setting it equal to then 4 and -4. And then that's the point when you're setting up your two equations and solving. Okay, now we're going to get into inequalities. Okay, inequalities are the thing that are next. So anytime you're asked to translate, what you're really trying to do is you're basically being told something in words. So you're being told x is negative. Okay, x is negative. What I really want you to do is basically think of how you would describe all negative numbers. And hopefully what you said for all negative numbers is they're just, well, they're anything that's smaller than 0. So really what you're going to write is x is smaller than 0 as an absolute value. Or not as an absolute value, excuse me, as an inequality. Sorry, I was still thinking of that first section. So you're just going to write x is less than 0. Okay, what you've basically done is you've described every single negative number using an absolute value. If it was positive, using an inequality. If it was positive, you'd have x is greater than 0. Okay. Now on to what will be the bulk of the work, and that's solving inequalities. So you're going to have to solve single inequalities. As we'll see kind of on those next couple of pages, you'll have to solve compound inequalities and absolute value inequalities. Okay. In all of these cases, you're going to be putting your answer on a number line. The reason you're going to be putting your answer on a number line is because there's really an infinite amount of answers for each of these. And so anytime in math where we've got an infinite amount of answers, a lot of times what we'll do is we'll put it in some kind of visual format, whether that be a graph or a number line, so we can get a visual display there. So for here, there's no setup. We're just going to take our inequality and solve it as normal. So I'm just doing the exact same thing I would do if I were solving an equation. The only difference in solving an equation versus an inequality comes right at the end here. Okay, so I divide both sides by -2. Anytime you divide by a negative, you've got to change the direction of your inequality sign. So I'm going to do 40 divided by -2. That gets me -20. And I'm going to change my greater than sign to a less than sign. Putting this on a number line, I'm going to put an open circle on -20 because I want to start there. But because it's not less than or equal to, I don't want that number to count. And then I'm going to shade left because that's where all the numbers smaller than -20 are. Oof, a little hard drawing on my tablet right now. Let me try that again. A little better. So that's kind of the basic method for solving an inequality, which is really kind of cool because, we don't have to learn anything new other than making sure that we flip the inequality sign around. Okay, that's the only thing that we have to do differently. And again, that's only when you divide by a negative. Okay. Looking at the other side now, solving compound inequalities, I've kind of given you the two major examples here. So this first one, number 5, it's written as a compound inequality, but it's written with the x in the middle of the two inequality signs. So you're basically going to be solving two inequalities all at the same time. Okay, so what you're going to do is you're going to add 7, but instead of just adding it 2 places, you're going to add it all 3 places. It's almost like there's 3 sides of the equation, and you're trying to isolate the x in the middle. So initially, I get 9x. I get a -27 over here, and I get a -72 over here. I'm going to divide by 9. Now, I'm not flipping my sign here. Okay, even though -27 and -72 are negatives, I'm not dividing by a negative. I'm only dividing by a +9. Okay, so I'm going to leave that sign just as it is. There we go. And what I get is that x is between -3 and -8, or that x is both less than 3 or -3, excuse me, and greater than -8. So I'm going to put circles on both of those, and I'll shade in between. Okay. In the other one, I've got 2 very different looking inequalities. And what's great about this is there's an or in the middle. I'm just going to kind of write that up top so I don't forget it. What's great about this is I can just solve both of these separately and completely independently from each other. They are not really dependent on each other. I just solve them both and see what the result is. Over on the left, I'm currently dividing by a negative. So when I divide by a negative, same as always, I flip my inequality sign. The same thing is going to happen over here. I'm going to subtract 10. Make sure to keep the negative, that subtraction sign that was before 3k. Keep that along for the ride here. Divide both sides by -3. And I have to flip my inequality again because I divided by a negative. Okay, so I'm going to rewrite my or down here. Anytime you see an or, you're really just graphing both of those ranges completely independently as well. You solved them independently, you're going to graph them independently. So greater than or equal to 1 is right there. Less than 8, I'm going to use an open circle. That's right there. All right. Finally, an absolute value with an inequality. The great thing about these is that you're not doing much more than we did right up here. You're just transforming this excuse me, into a compound inequality. So our rules for transforming it: write the original without the inequality symbol. Then write it again, flip the inequality symbol, change it to a negative. That's it. Okay. Then to decide whether it's going to be an or an and, you're looking all the way back at that original symbol. If it was a greater than or greater than or equal to, in this case, you're going to use an or. If it was less than or equal to, you'd use an and. Again, solve them both independently of each other. So in both of these cases, we're going to add 7, and we're going to divide by 2. So for the first one, I get b is greater than or equal to 4. Add 7. 2b is less than or equal to 6. Divide by 2. And I get b less than or equal to 3. Put that on my number line. And I'm all set. And that's really pretty much all we've got here. A couple different questions that popped up throughout. Okay. Block 5, yes, you are on your 50 tomorrow. Anybody that's not at school due to Rosh Hashanah, that's no worries. You can take that whenever you get back. We'll schedule when we get back. Hayden asked, where did the or equal to go? Why did you get rid of that? I can go back and check and try to figure out where I dropped it. I don't recall dropping one. If something started with an or equal to, it should finish with an or equal to. I am trying to figure out where I lost it. Number 6 started off with 1 that had an or equal to and 1 greater than. Oh, I see where I lost it right here. Number 5. Thank you, Hayden. I totally missed it. I didn't even see it. You're right. That should be an or equal to there. So that should actually be solid. So Hayden must have been referring to number 5. Sorry, guys. I have to jump back and forth between looking at the chat window and looking at what I'm writing. So sometimes I don't see the questions exactly when I probably should. Okay. Thanks for noticing that one. Yeah, you should never get rid of the or equal to piece. Okay. So hopefully all this was good. A couple notes just that I'm thinking of off the top of my head that I know might help you guys out. If we're looking at an absolute value equation, we should have 2 answers, and that's kind of important. Okay. Even if you look at the very end, oops, too far. If we look at the very end, we had an absolute value inequality, so it didn't even have an equal sign, had a greater than or equal to sign. We still set up 2 equations. Okay, so that whole idea that absolute values turn into 2 answers is kind of an important one. And then just making sure you know how to put your solution on a number line. Okay, that's kind of a big deal as well. Okay, those are kind of the major points. Okay. Aaron, you're asking a specific question about a concept quiz. There shouldn't be much in the way of decimals here. If they are, typically on tests, I will try to make them pretty nice decimals. Okay, so I'll try to make them end in something like a 0.5 or something like that, just because that does keep things easier. Okay. And Hayden asked one more question. Let's see. Don't you have to fill in the circles on the last one? The answer might be maybe. Let's see. Did I miss some more filled in circles? You're right. I missed some filled in circles again. So that'll make it. We'll make that my last point then. This is a good thing to go back and double check. So like if I were actually taking this as a test on test day, I would go back and I would look through all of these different symbols. Okay. And what I would probably do to check all of these, good thing I made so many mistakes at home. Otherwise, we wouldn't have noticed this one, but this is kind of cool. So look, if I were checking out number 4, I would probably do 2 things. One, I would check out to make sure I have the right symbol on the 20. It's a greater than. It's not a greater than or equal to. So I should have an open circle. I'm good there. The other thing that I would do is I would check kind of a random number that's either in my answer range or maybe even one that's not supposed to be in my answer range. Like for this one, I could check 0. Zero's somewhere kind of way over here. I could check that out and it shouldn't work. And sure enough, it doesn't, right? If I plug in 0, I get -4 is greater than 36. So that's at least some indication that I probably did that one right. I would kind of go through and do that for all of them, right? So in number 5, I should have 1 filled in and 1 not filled in. So that one turned out okay. In number 6, I should have 1 filled in and again 1 not filled in. So that looks okay now. And in my last one, they should both be filled in because they were both greater than or equal to, or they were, one was greater than or equal to, one was less than or equal to. Those are good little things to go back at the end and just kind of check out to make sure that everything worked out okay. All right. Looks good. If you have any other questions, feel free to stop by real quick in the morning or stop by at recess tomorrow and just let me know any kind of final questions you have. If not, best of luck to everybody on their test. And if you're watching this later, same to you. If you have any questions, feel free to stop by and ask during recess. Okay. That's it. Hopefully this was at least a little bit helpful for you guys.